The Network Composer is the environment provided by the AstraKode Blockchain Platform to design and develop Hyperledger Fabric networks. To access the environment, one must create a project of type network. To do so, once in the platform's homepage, there are two ways to create a new project. You can either use a pre-built solution centered around a specific use case, or start from scratch. In our case, we're going to start from scratch. After providing some info and metadata for the project, we can select the network project type, and Hyperledger Fabric will be automatically chosen as the relevant technology. Once the loading has finished, we are met with the Network Composer environment. On the top of the Composer, one can find the action bar. Here it is possible to save the project, toggle its settings, undo or redo, share the project with another user, generate the project's code, close the project, or toggle the autosave. The left bar of the environment is dedicated to the definition of the two main global components of the network, the partaking organizations and the consortia they form. On the right bar, one can find the project's validation tab, which will signal any issues currently outstanding. As you can see, as we just started the project from scratch, the bar is currently flagging the absence of organizations in the network. To provide extra room for the visual development, the validation tab can be collapsed or expanded at any time. It is now time to get started and define the network's organizations. To create a new organization, one can click on the plus button in the dedicated tab in the left bar. This will trigger the appearance of the organization's creation model. As you can see, all necessary settings are already defined by the platform by default. Next to a name, an organization's type needs to be defined, as well as one or two certificate authorities for that org. Even though a CA is already defined by default, we're going to change its name to reflect its association to the newly created org. Here we can also decide whether the CA is able to emit TLS, MSP, or both types of certificates. For simplicity, we are defining our CA as dual. Furthermore, as the CA operates within a Docker container, it is also possible to change that container's port. After this, we can save our organization and it will appear on the left bar under the relevant tab. We can always go back and change any detail about the organization by clicking on the Edit button under the organization's card. Now, we repeat the same process to create another client organization. Once the two sample client organizations have been defined, we can proceed with the definition of the orderer org. The process is the same, however, we need to define this organization's type as orderer. As you can see, the validation bar is already hinting at our next step, which is to define at least one consortium for this network. As there are only two client organizations, it is natural that there will be only one consortium with both of them present. As soon as the consortium is defined, it will appear on the left bar under the relevant tab. As with organizations, we can edit this consortium at any time. Once a consortium is defined, the platform automatically creates its first channel implementation. As already mentioned earlier, a consortium can have as many channel implementations as one sees fit. The channel implementation is shown in the visual environment at the center of the screen. In fact, this visualization of the network represents its topology. We can see that together with the channel, the platform has also created two peers and an ordering service associated to that channel. A channel's configuration tab will let users define which subset among the consortium members will transact in that channel. In our case, both organizations will transact, and thus be part of the channel. It is now time to configure our peers. Similarly to other components, a peer's definition tab will also be configured by default by the platform. As you can see, a peer's settings revolve around some metadata such as its name, the organization that owns that peers, the type of service called to connect to the peer, and a few network settings such as whether it is an anchor peer and the ports at which the peer and its chain code are accessible. As with the certificate authority, Hyperledger Fabric peer also run within a Docker container. We can now set our second peer to be owned by org2. Once this is done, each organization will have one peer connected to this channel. It is finally time to configure our ordering service. Its definition tab is configured by default. However, for redundancy, we are going to add two new nodes to the service. For each node, we can configure its name as well as the port at which it will be accessible. An ordering service node also runs within a Docker container. Once this is done, we can see that the validation tab shows no project issues and we can thus proceed with generating the network. As soon as the generation process is finished, it is time to select on which operating system the network will be running. In my case, I will select Windows as I'm utilizing a Windows machine. After this choice, we can download the generated network. At this time, if we click on the Instructions button, we are redirected to the Hyperledger Fabric documentation page, highlighting all necessary prerequisites to run the network. However, such information is also available in a PDF guide contained within the downloaded network project zip. This guide also provides a walkthrough on how to run the network and install chaincode on it. The other relevant components of the downloaded project are the BC network and chaincode folders. The first contains all assets, scripts and configuration files for the network to spin up. The second contains a few default chaincodes as well as a structure to add one's own chaincode and easily deploy it to the network. To actually spin up the network, it is enough to open a terminal, move to the BC network folder, and trigger the network.sh script, providing the app argument. Finally, to take a step back, it is important to underline that for each component and configuration, the platform provides both contextual help in Platform as well as a comprehensive wiki to both explain the relevant concepts as well as guide users to a correct configuration.